first day, it's kind of just a big vocab day. We're going to learn a few different vocab terms, and we're going to learn about our three-dimensional shapes. I'll break out some props tomorrow so you can really take a look at those three-dimensional shapes. But for today, our first vocab word is a cross-section. A cross-section is the intersection between a solid, which is what we're going to call our three-dimensional shapes, and a plane, which is like two-dimensional planes. We think of like sheets of paper. Those are planes. So for cross-sections, we're going to have a lot of different kinds of cross-sections. You can really cut a shape any way you want to. Imagine you literally slice through it with a sword. You open that shape up, like imagine Fruit Ninja. You guys play Fruit Ninja? Fruit Ninja? Okay, you open that shape up. What's on the inside? What flat two-dimensional shape is looking at you? Are you looking at a square, a circle, a triangle? That's going to be the shape of your cross-section. Next is a net. We're going to be drawing cross-sections and nets. This is kind of a drawing-heavy unit. We're going to be drawing quite a bit. A net is what happens when we take a shape and we unfold it to be flat. So we take a three-dimensional shape, you unfold all of the pieces, it becomes a flat piece. Imagine if you're like sewing or you're making clothing. You start with a flat outline. You sew those pieces together to make a three-dimensional piece of clothing. That's essentially what we're doing here. Imagine back in like first grade, you were cutting things out, pasting them together to make three-dimensional shapes. Then ultimately, our goal is to use those nets to help us find surface area. Oh my goodness. So we're going to use nets today to help us find surface area. Surface area is the sum of all the areas of all of the faces of a three-dimensional figure. So what is a face? Let's really get into that vocab for our three-dimensional solids. Any three-dimensional solids that has flat faces or flat sides, flat surfaces, we call polyhedron. Poly meaning many, hedron meaning faces. It's literally like a direct translation from Greek or Latin or whatever it is. So it is made up of these flat surfaces. Flat surfaces are called faces. We also see them called sides. They're kind of interchangeable. They mean the same thing. And those flat faces that we're going to see are shapes that we already know. Squares, triangles, hexagons, pentagons, whatever they are. They're all going to be polygons we're familiar with. When I connect two faces up, like imagine we're welding and we have a seam in the middle, connecting two faces up, they're joined by edges. Edges are segments. And then if I have two edges that meet at the same spot, we call that a vertex. Vertices are points. They are points where two or more, three or more edges intersect. So we will have to know the differences between faces, edges, and vertices. Those are vocab words we're going to use all of the time. And then let's talk specifically about the different kinds of shapes that we are going to see in this unit. There's two main bases of shapes that we are going to see. The first category, I don't like how this is. I'm going to put these together. Cylinders and prisms. I consider the first kind of subset of 3D solids that we're going to see. Prisms have two parallel congruent faces that we're going to call bases. So in this example, down at the bottom in the middle here, we have a prism that has two bases. Now the bases can be any kind of shape that you want. They can be rectangular, which a lot of the times they are rectangular. In this case, the bases are pentagonal because they have 5 sides. And we see that they are across from each other. They are parallel from one another. That is how we know that this is a prism, because it has two parallel bases. Then we have a fancy kind of prism, which is when our base is circular. We give it a fancy name. We call that a cylinder. But a cylinder still has two bases. Its bases are just circles. Okay, good on that? Prisms, cylinders kind of go together. Then the other subsection that I see is pyramids and cones. So similar to the prism, a pyramid also has a base. However, it only has one base as opposed to a prism that has 2 bases. Again, for a pyramid, these bases can be any shape you want. Oftentimes, triangles, squares, hexagons, pentagons, whatever shape of base you want to see. There is one of them. And then it comes to a point up at the top. We call that the vertex. If we have a circular base, we call that a cone. Again, just one base. And then it comes to a point up at the top. Cone is a fancy pyramid. Those are our 2 main subsections of shapes, and they each have one that's fancy for circles. Any questions on that? So, of the 2 main subsections, prisms and pyramids, we can get more specific when we name them, and that second name comes from the shape of the bases. So, in this first, on the left here, we have all of our prisms. We know that they're prisms because they each have 2 bases. Let's highlight the bases here. So they each have 2 bases, and they're parallel from one another. And then we can add in a more descriptive name by calling them by the name of their bases. So triangular base is triangular prism, rectangular bases, rectangular prism, or pentagonal bases for a pentagonal prism. Same thing here with the pyramids. Oops, different color. We can also name them based on their base shape. Remember, pyramids only have 1 base each before they come to a point. So I have a triangular pyramid, a rectangular pyramid, and a pentagonal pyramid. Okay, that's our vocab. Are we good on the vocab? Lots of vocab. All right, let's talk about cross sections. So again, we're thinking like Fruit Ninja. I'm cutting these shapes. I can cut them horizontally. I can cut them vertically. I could cut them diagonally. We might also see some other vocab used. So for letter A, it says find the horizontal and vertical cross-section of the figure. The one that's already drawn for me is the vertical cross-section. So I'm going to kind of outline this shape in here. We're imagining slicing this cylinder through the middle vertically. Oops. And then it kind of depends on the orientation of how your shape is. Maybe it's laying on its side, maybe it's standing up on its base. We also might see vocabulary that looks more like, it looks more like this. We would call this a cut that is parallel to the base because it's going in the same direction that our other 2 circular bases are going. So this particular vertical cut is parallel to the base, and it forms a circle as its cross-section. We then also are going to cut this shape. I'm going to erase some of my markings here. We're also going to cut this shape horizontally. And in this case, horizontally. In this case, we might call a horizontal cut perpendicular to the base. And we might have to draw it out here, but I'm going to make this horizontal cut, and then I'm going to do my best to kind of outline what shape this is. Maybe. There we go. Do we see the shape that is formed if I cut this horizontally? It's kind of hard because it's a 3-dimensional figure on a 2-dimensional surface, so you got to use a little imagination here. That would be a rectangle. A lot of the times in your homework, it'll also ask you to draw the cross-section, so maybe just get in a habit of kind of doing that off to the side. Okay, so in letter B, same deal. Find the horizontal and vertical cross-sections. This time, horizontal. Our horizontal one this time, this is going to be parallel to the base. Because if I cut this horizontally, we have to imagine. Oops, I don't like that line. You got to imagine I'm cutting like the top off of this here pyramid. Okay, and if I think about cutting the top off, what shape am I going to see when I open that up? That would be a square. And then maybe a little bit harder to see if I cut this vertically, meaning up and down. This time vertical is perpendicular to the base. Vertical cut is going to look something like this. that vertical cut through that shape is going to make a triangle. That's only if we cut straight through the middle, by the way. We have to cut through the top of that shape. Okay, any questions on that? You're essentially going to be naming that two-dimensional figure that you get when you open it up. Flip it over. The next thing we're going to talk about is nets. Nets get a little bit tricky. It requires a little bit of imagination here. In letter C, we're going to draw the net of these figures. First of all, I got to know what kind of shape I'm looking at. So this shape right here, it's got rectangles and it's got triangles. Faces, like side pieces, can only be rectangles. Bases can be whatever shape we want them to be. So in this case, I see these two triangles. I know that these two triangles have to be the bases of my figure because regular faces cannot be other shapes. So those two triangles are the two bases. I have two of them, which tells me this is going to be a triangular prism. And I'm going to start to unfold this. The way that I like to unfold my shapes is to imagine the way that they're sitting right now is them sitting on a table. If you imagine this shape sitting on a table, this part is the part that's touching the table, right? So I'm going to start with that shape right there. Every other piece is going to unfold from that piece. So those triangles that are on the base, they are going to unfold to the sides. Again, using your imagination here, I know it's kind of tricky, but unfolding those two triangles to the sides. This piece standing straight up on the back, I'm going to unfold that upwards. And then this piece in the front, the slanted, the hypotenuse piece, I'm going to unfold it downwards to the front. Your net might not look exactly the same as mine, but as long as you've unfolded your pieces in a way that makes sense to you, they're connected, I see all of the different sides laid out flat, you should be fine. In the next shape, it has a circular base, and that base, there's only one of them. So this is a pyramid, a circular pyramid, which we call a cone. I'm again going to start with the piece that I see is like on the table, that's sitting flat. And then I'm going to unfold the rest of it. You have to imagine in this one that we're like cutting a line down the middle so that we're allowed to unfold this curved face here. And this is just a weird one. We get like a weird, like a pizza slice kind of shape here. So like one of these sides right here is one of these guys. Maybe mine was way too big, but it's okay. We get the idea. Okay, we understand the nets a little bit. Let's do another net. In letter D, now we're starting with the net. We got to figure out what shape this is. So I'm looking at number 1, how many bases do I see? And number 2, what shape are those bases? What do we think about letter D? Yeah, Caitlin. It is a rectangular prism. And for rectangular prisms are a little bit weird because any two pairs of opposite sides could be the bases. That's not true for every shape. Remember, in our triangular prism, we had to pick the bases to be the triangles. But for this guy, I could say these two pieces right here, those are my bases. And that would be totally fine. You could pick any other two pairs that are parallel, and you would be correct. This is a rectangular prism. Okay, good on the nets. Now, we're doing like a little step before I teach you all the shortcuts and the surface area formulas. We're going to use the nets to help us find the surface area. So we've already seen this shape before. I know that this is a square pyramid. The base is a square. It's only got one base. It's a square pyramid. I'm going to first unfold this square pyramid, and then I'm going to use that net to help me calculate the surface area. So on your papers, I want you to start with the square that's like touching the table here. Unfold the rest of your pieces, and then as you are unfolding them, there's some labels on here that tell us some dimensions. I want you to add those dimensions into your diagram. So go ahead and do that for me really quick. I'm going to start with this square here. My square is like 12 by 12. Oh boy, we're getting real tiny. And then I'm going to unfold each one of these sides. If I could switch color, that would be fantastic. Or maybe not. Maybe the whole thing's just going to freeze. Okay, does your shape look something like this? Maybe it looks a little bit different. Maybe you connected your triangles up in a different way. This is how I see it. I also need to add in that one of my triangles because of this line right here. The height from the middle of that triangle is 5. I wish I could do this in other colors, but it's not letting me switch. Okay. So those are my shapes. Now I'm going to use that net to figure out the surface area. Surface area is just flat surface area of all of the outside pieces. So I first see that there's a square in the middle. Surface area, we use SA for surface area. The bottom of that square is a 12 by 12 area. Oh, goodness. This thing is not cooperating today. Sure. By 12. And then I have to add up all of those triangles. So I see that there are 4 triangular faces. So 4. The area of a triangle is 1/2. The base of those triangles are each 12. And the height of each one of those triangles is 5. I can do a little bit of simplifying here. This is 144 plus 1/2 times 12 times 5 is 30. 4 times 30 is 120. This should be 264. And then I need units. What are the units for surface area? Centimeters, what? Centimeters squared. It's the same as regular area. Oh my goodness. There we go. Okay. Let's keep moving. Things get a little bit weird when we have more complicated shapes. So if I take a look at this guy, I see 2 bases. Each one of those bases is an octagon. Again, I like to kind of start with the piece that's on the table. Not really a table, but like you're imagining it's on the table. So I'm going to start with that little rectangle right there. And then from that rectangle, I'm going to unfold those octagons. So I'm going to have an octagon up here. And I'm really, really good at drawing octagons. You'll get there one day. There it is. Perfect. And then there's another octagon. Okay, because I have 2 bases. And then I can kind of figure out how many of those rectangle pieces do I have. So if I count them up, 1, 2, 3, 4, 5, 6, 7, 8. I should have 8 of those little rectangular pieces. So I'm going to draw 8 of them somehow. If I can fit them all in here. 1, 2, 3, 4, 5, 6, 7, 8. When we're drawing these nets, we need to make sure that we add in some labels. So the length of one of those rectangles, or aka the distance between the 2 bases, is 23 yards. One side of my octagon is going to be 5 yards. And then one height of my octagon, from bottom to top, is 12.1 yards. Everybody cool with that? Now we got to figure out the surface area of this shape. I see 2 octagons and I see a bunch of rectangles. So let's call this SA for surface area. I'm going to start with my 2 octagons. So I'm going to do 2 times the area of an octagon. The area of an octagon formula, regular polygon, 1/2 apothem times perimeter. Perimeter shouldn't be too bad for this octagon. Each side is 5. There's 8 of them. The perimeter is 40. Anybody know how we find the apothem of this shape? Aubrey? Yeah, it's half the height. The apothem starts right in the middle. If the whole height is 12.1, then the apothem here is 6.05. So this is 2 times 1/2 apothem times perimeter. And that's for our 2 bases. And then I need to add on all of these little rectangles. I could do 8 times whatever one rectangle is, or I could figure this out as one big rectangle. This is one big rectangle. The height is 23. If I add up all of these little pieces, the width of this rectangle is 40. Put it all in my calculator. It's not too bad to simplify by hand if that's what you want to do. 2 times 1/2 cancels itself out. So the surface area of this whole shape, after all of that work, is 1,162. We have yards, and our unit for surface area is always units squared. Any questions? I got one more, and then we're done, I promise. Things get a little tricky in this guy. Let's draw the net. It's a cylinder, so there's 2 circular bases. So let's draw those 2 circles out. And then in the middle of those 2 circles, this shape, this curved surface, is going to unfold to make what shape? A rectangle, right. Just because it's curved doesn't mean anything. When we unfold it, it's going to make a rectangle. Let's put some labels in there. I know the height of this rectangle, or AKA the distance between the 2 bases, is 10 centimeters. And then I know one diameter of one of these circles is 14 centimeters, which is not drawn to scale. You're just going to have to believe me. So let's start surface area. I have 2 of these circles. So we're going to do 2 times the area of a circle, pi r squared. We remember the area of a circle formula? The radius here is 7. So this is 2 times pi 7 squared. That's the first part. The second part is a little bit tricky. For this rectangle, I know that the height is 10. How am I going to figure out what the base of that rectangle is? Allegra? It is the circumference of the circle. We know that it's got to wrap around the entire circle. So this base is going to be the same, is going to be the same as the circumference of that circle. Circumference is 2 pi r, or we could just call it pi times diameter. So this is 14 pi as the width of that rectangle. So 10 times 14 pi. You could put this all in your calculator. I like to simplify this down. It's not too hard to simplify. 7 squared is 49. 2 times 49, 98 pi, plus 140 pi gives me 238 pi, I think. Or if we want to round that 238 pi, we should get 747.7 centimeters squared. Any questions on that?